very excited to just be kind of bringing everything under the new banner. And yeah, so this is the LA360 VR AR developer group. Very nice and long and fun title. My name is Garrick. I'm representing Castle Step Studios, which is this fine location. We're going to be opening back up to the public. This weekend's going to be beta testing, and then the weekend after. We're a virtual reality location-based entertainment development studio with a brick and mortar location, as you can see. And we love to just do community events, have meetups, all that fun stuff. And so we're really glad to have you all here. Yeah, we've got some great speakers tonight. We have a great partnership with Kronos and a great new merger coming up with XRLA and Nima, actually, if you want to talk a bit more on that.
Hey everyone.
Hello.
So welcome. This meetup group has been super awesome. It's one of the largest in LA. I never can say the name. It's like 360 AR VR developer, whatever. It doesn't matter. But it's the largest active XR community meetup in Los Angeles. And we a few months ago started a new meetup after. History of it's like there was a meetup that we wanted to plan after the USC VR hackathon. A bunch of people made some really good connections, and we just wanted to get together and continue to meet and talk about the different technologies in the space. And so we started a group called XRLA. XRLA grew really quickly. We hit the maximum meetup group super quick, and we were thinking, okay, well, should we start like paying for like more meetup space? Like, what's the next step? And anyways, we decided instead to try to join forces with other groups in the area. So this is the first step towards doing that. We want to build a unified XR community in Los Angeles. And so now we are merging with the 360 AR VR developer meetup. Doesn't matter. We are now just XRLA. And so yeah, welcome to XRLA, everybody. And we're going to continue to make this as kind of like an overarching community group where people come to share things, show what they're working on, connect with each other for like gigs, look for talent, talk about the cool new stuff that's going on. If you want to go to the next slide. We already have, oh, it didn't update. Oh well. Refresh that page. Cool, well we already have, yeah, there we go. So we have a Twitter, XRLA, at XRLA community. That's our meetup group.
You now have McAfee?
Do have antivirus, amazing. There we go. We have a Facebook group, and we have an active Slack channel where people are posting their things. So if you want to take a picture, join the social groups, and join part of the community. In the future, we're going to have our own calendar that has all the different events in the area. We'll be partnering with a lot of other meetups. We're already in talks with other meetups that are very interested in what we're doing. And this is going to be like the community meetup. It is run by the community and it's for the community. So if you want to be a part of it, just come talk to us. Does everyone want to be part of it? Want to come up here for a minute? Let's do the thing.
So is ARLA now going to be XRLA or?
I have
This
no
is
idea
not
what
ARLA. This is
Okay.
a different meetup.
Okay.
They help promote though. They're one of the
Paul Roth, it's
Yes.
a really
Okay.
good friend.
So
Do
this
you guys
is,
know Steve
yeah.
Areno from the VRLA group?
I do not. I do know that Cosmo and John Root, who are two like the main founders of BRLA, we actually like told them about our idea for XRLA before we did all this. Yeah, they mentioned they don't do meetups anymore, so they thought like.
No, there's another group, VRLA. It's just taken over by a new guy, still Steve Areno. I'll set you guys up with him. He's awesome.
So it's not related to the VRLA conference?
Not the conference.
Oh.
They gave it up. They gave up the group, and this guy just took over.
Interesting branding.
Yeah, crazy. Okay, well, this is XRLA. We have a bunch of cool events coming up. We've got one planned for next month. We're going to have some really cool speakers. So please join, and we'd love to see you guys in future meetups. Thank you for coming.
Okay, don't move for 2 seconds.
They moved.
I know, they keep moving. Oh well, it's just going to have to be blurry. Thanks.
Okay. Sorry. All right. Well, thanks, guys. I hope you enjoy the speakers. They are super awesome. So hope you enjoy it.
Give me like 10 seconds. I'm just going to close this gate because it gets kind of noisy inside.
Hey guys, I'm Matthias. I've been working in the VR space for about 4 years now. Moved out to LA about a year ago, and I work with a design agency called Klooge. But I'm not here to talk to you about any of that stuff. I'm here to talk to you about our awesome sponsor, which is the Kronos Group. So if you liked all that pizza and drinks that we had over there, that's all thanks to the Kronos Group. And they are an awesome sponsor, not only because they give us free food and drinks, they're an awesome sponsor also because they're an awesome group as well. They're an open source consortium that creates royalty-free standards for graphics, AR, VR, neural networks, parallel computing, and vision processing, all sorts of really cool things. They're totally open source, they're royalty-free, they're not making any money off this, and they're an organization of a ton of different top companies working in the AR, VR space, everyone from Microsoft to Facebook to Google to, I mean, if you think of a big name that's working in AR, VR right now, they're part of it. And they're working on something that's actually not listed up here, because this is the list of all their standards. You'll probably recognize a number of these. You've probably worked with a bunch of these. And that's thanks to Kronos. They're the ones that are creating all that awesome stuff. And they're also working on something that we're really excited about, which is called OpenXR.
Woo!
Yeah. OpenXR is going to be an open source standard for creating AR and VR experiences that will allow you to essentially build once with any platform and deploy to a number of different AR and VR platforms as well too. So it's going to be really cool. They have all the right players involved to actually do it and do it right. And so it's going to be pretty awesome. But so yeah, if you like the pizza or the soda, or you like open source standards, or you like AR and VR, feel free to tweet at them and let them know how much you appreciate them, because then we can get more sponsorship for this stuff and get more pizza and stuff in the future. So thanks so much, guys, and yeah, enjoy the meetup. We have our first speaker, which is Steven Frisbey. He's the production manager and senior strategist for Experius VR, which is an awesome local company. They went to Egypt to film or shoot Queen Nefertari's, which I might be butchering, tomb using photogrammetry and 3D scanning. And they're going to tell us all about how they did that, and so that you can learn how to shoot for photogrammetry as well. So please welcome Steven. Thank you.
Hello, everyone. All right, just give me 1 second, please. All right, so my name is Steven Frisbey. As mentioned, I'm with the production manager for the project, which we ended up naming Nefertari Journey to Eternity. So Nefertari Journey to Eternity is an edutainment experience that was based around photogrammetry and 3D scanning. So everything that you see inside the tomb when you go inside it in VR is exactly what we saw the day that we shot. So a bit of an introduction, if you can go ahead, next slide. So an introduction, our company is called Experius VR, and we're focused mainly on cinematic virtual reality. So our main goals are to create the highest level of visual quality possible in VR at any point in time. We partnered with CuriosityStream. One of the co-founders of Experius VR is named Andrew Hendricks. His father is John Hendricks, who is the founder of the Discovery Channel, back when it was still awesome and everybody loved it. So he kind of got sick of the way that the direction that Discovery Channel was going. So he started up CuriosityStream, which does pretty much the same thing as it used to, except now it's kind of like a Netflix style setup where you can pay $9.99 a month and get unlimited streaming for the best documentaries and that type of content available. So we partnered up with CuriosityStream. They pretty much funded the entire project and gave us free rein to do it as we saw fit. We spent about a year or two in research and development, just learning the basics of photogrammetry and 3D scanning and how all this stuff works together. And when we finally felt like we were ready, we went ahead and put this project together. So we were able to partner up with a bunch of really cool companies. We worked with Google. They lent us one of their jump cameras, so we did a 360 experience alongside a photogrammetry experience. We worked with Leica Geosystems, who lent us their BLK 360 scanners, which we used to scan the tomb. One of our other awesome partners was Simon Che de Boer and his team at realityvirtual.co. They were a big part of getting the photogrammetry looking as perfect as we had wanted it. We hit them with a pretty hard challenge. Most of the photogrammetry that we've seen over the last couple of years has always had something wrong with it in one way or another. The main thing that I've never liked is baked-in lighting. So most people, when they shoot photogrammetry, they shoot without doing any kind of any special techniques for their lighting. So when the model is finished, you'll notice the shadows of all the lighting is burnt into the textures. So that means that you can never reuse that asset for any other purposes because you're stuck with that one individual style of lighting. So that was one of the big challenges that we were really focused on achieving, was making it so that the entire environment was fully delit, and so that we could change the lighting and everything else we would need to across many different circumstances. We can go ahead and the next slide, please. So I started giving a little bit of an overview overall, but so basically from start to finish, we ended up flying out to Luxor, Egypt, into the Valley of the Queens. We shot Queen Nefertari's tomb along with a couple of other tombs that I can't discuss at the moment, as well as a ton of artifacts from the Luxor Museum and the Cairo Museum. So we did 3D scanning, we did the photogrammetry, and if anybody here doesn't know what photogrammetry is, basically we take thousands and thousands of pictures of an object or an environment, and then we use 3D software to recreate the geometry and the textures based on all the different photos we took from all the different angles. So when we mix that with 3D scanning data, we're able to get sub-millimeter accurate geometry data, and the photographs give us the highest quality texture data possible. Next slide, please. So as mentioned, this is located in the Valley of the Queens in Luxor, Egypt, which is pretty much right next to the Valley of the Kings, where all of the famous tombs are. You'll find King Tut's tomb there, you'll find King Ramses, you'll find pretty much all the big dogs from back in the day. So Queen Nefertari was the favorite wife of King Ramses the Great. He had a bunch of wives, but she was his favorite, so he built her this amazing tomb. One of the reasons she was the favorite was because she was a respected politician and strategist and leader in her own right. She provided a lot of input into war strategy, political strategy, things along those lines. So the main reason that we chose this tomb in particular was because of the amazing amount of detail that is in these paintings in this tomb. When we first went for our scouting trip about a month or two beforehand, when we first got there, we saw all the paintings and they were perfect. They looked like they were just painted yesterday. And myself and my partner were pretty sad because we thought we weren't going to be able to shoot it because we thought that they had repainted it. So we went to the guys that we were working with and asked them about it, and they said, no, this is all the original paint from 3,000 years ago. So once we found out that it was all legit and original, we decided this was the one for us. So as mentioned in the slide, her tomb is so well preserved that it's referred among scholars as the Sistine Chapel of ancient Egypt, because there is no other tomb in all of Egypt that has this level of quality of paint still in full, still in good quality. Good. Slide, please. So I think I already mentioned, but the real goals of this project was to showcase the art of photogrammetry and 3D scanning by documenting a World Heritage Site. As mentioned, we've done a bunch of different projects with photogrammetry already, but to do something that we could share with the world that means something to the world was really a big goal of this thing. The second main goal, and probably the most important goal for me personally, was to set a new standard for visual quality in virtual reality by creating a fully delit model that can be reused in endless scenarios. So as mentioned, we've seen a lot of photogrammetry so far. The biggest things that are missing are they're not delit, and the second thing is that a lot of the geometry gets left very dirty. So when you go into some of the smaller or hidden areas in a lot of photogrammetry experiences, you'll see a lot of really dirty geometry, really messed up, blurry textures. And that was something that we weren't willing to we weren't willing to settle for that. So we decided to go all out and see what we could do. You can go ahead and next slide, please. So at the end of the day, I think we did a pretty good job, and we have a demo set up. So I hope everybody gets a chance to take a look at it when it's finished. We've also released this experience for free to the public. We know that this is a huge data set. The final download, I believe, is 14 to 15 gigabytes. And I know a lot of people, for such a small experience, they're not really going to want to pay a large amount of money and have this big thing sitting in their hard drive that they're not going to use constantly. So both 3D scans as well as standard photogrammetry by adding thousands of pictures. Autodesk Maya was used for 3D modeling in post. So as mentioned, we didn't want to have any dirty geometry, so we had some really great 3D modelers come in and clean up any of the dirty areas, as well as play around with some of the textures. Which leads us to Substance. The Substance suite is really great for painting in 3D. So it's kind of like the Substance Painter, I believe it is kind of like Photoshop for 3D models. Makes it a lot easier to work with instead of dealing with
Substance Designer.
Is it designer?
Yeah.
Okay, yeah. So they got designer, they got painter, and creator.
Yeah.
Yeah. So ZBrush is another 3D modeling software that we use for cleanup. ZBrush is a little bit more of a fine-tuning 3D modeling software. It's a little bit complicated to understand, but once you get the feel of it, it's amazing software that feels very intuitive. That strange little icon over there is Leica Geosystems Cyclone. That is another 3D scanning software. They'll take the object face on. So instead of having it off-centered to where it can capture two faces by scanning at the corner, they'll scan, face to face, back and forth. And by doing that, you're going to end up with a lot more scans and a lot of extra data, which is not needed. So one thing to consider when you're doing a 3D scan is taking into consider parallax and the different angles you can place your 3D scanner in to maximize the usage of it. Sorry, 1 second. You can go ahead and take the slide, please. So as mentioned, so this is the VLK 360 scanner right here. Very, very small, fits in a bag, size of a carry-on, so you can take this on with you onto an airplane. Very, very easy to use. So basically, you're just going to set up your scanner in the area that you want it. You're going to take out any objects that you don't want to be scanned. So in this room right here, we had some ducting along the floor that was used to maintain an optimal temperature. We had a couple fire extinguishers, some sandbags. So I made sure to remove all those so that they wouldn't be in the final results. So once you've done that, you basically just press a button on the scanner. You get out of the way. You make sure that you're not in the shot. It takes about 5 to 8 minutes for the VLK 360 scanner. Once it's finished, it'll beep. You'll walk back up to it, and you will align it with the previous scan. So this is you'll do this each step throughout the way, as shown in those stars on that last map. So as mentioned, it pretty much does all the work for you. Once you finish with all of your scans, it will turn it into one final object, and you can go ahead and change the slide. And basically, that's what you end up with at the end of the day. Now, there's not a lot of user input that you need to do. So if anybody here is interested in 3D scanning, something like the VLK 360 would be the ideal thing for you to start out with, because there's really not much you can do to mess it up.
Did you compare it to a Matterport?
I'm sorry?
To a Matterport? What's the difference between the two?
So Matterport is kind of a similar thing. It uses a LiDAR scanner, but it also uses photography. We couldn't have tourists in there. We couldn't have workers in there. So we had to rent these places out from, I would say, we started at 6 at night and we would end at 6 in the morning. So we had the coolest experience of being, like, I was in tombs just by myself for hours at a time. Weirdest, craziest, coolest experience I've ever had. But yeah, so we had to do it at night so that we wouldn't have any issues with people walking in our scenes or anything like that. So yeah, the scans are super fast. The scanner that I used previously was the Faro 350, I believe it was, and it took about a half an hour to get a high detailed scan. This one takes me 8 minutes for a high detailed scan. It's not quite as high detailed as the Faro, but it definitely gets the job done for what we need. So super fast, unparalleled ease of use by far. One button press, and that's pretty much all you need to know. It really couldn't get any easier, I don't think. The portability of it was very big. The scanner, I believe, runs around 15,000, and we were borrowing it. So when we took it to Egypt, one of the biggest concerns was it getting lost in the luggage. So thankfully, I was able to carry it in a handbag. It's small enough to carry with you. It's light enough to take with you wherever you want to go, maybe 5 pounds at most. So yeah, the portability was just absolutely awesome. And yeah, basically it's ideal for everything I just said, quickly and easily capturing a high quality point cloud of almost any environment. And now we can move on to the next slide. So now we'll be getting into the photogrammetry portion of it. As you'll see, here's our good friend Simon Shea DeBoer. He is an amazing photogrammetrist, and he was the director of photography for the project. So let's go to the next slide. So some of the basic equipment we used for the photogrammetry portion are listed here. As you can see, there's not a lot that goes into it. You basically just have to have a good camera. And at the end of the day, you don't even have to have a really good camera. If you wanted to start playing with photogrammetry now, you can just take your cell phone and start scanning objects. You'll basically take pictures all around in every single direction you can. And then you can go onto the Reality Capture website, download a demo, and you guys can get started doing photogrammetry on your own super easily. So we used the Nikon D810 camera, high-end full-frame camera with, I believe it had 48 megapixels of visual quality. That's very important for the level of detail we needed. We use Nikon lenses, 24 to 70 millimeters. I personally prefer prime lenses so that you don't end up messing up your focus, but Simon's a pro, so he didn't need it. We use polarizing filters to remove any reflections, to remove any reflections and help deal with our unique way of capturing with flash. So we used a couple flash lighting kits as well. These were pretty expensive and pretty heavy duty flash kits. We needed to have large battery packs that we carried on site with us. They were large enough that we needed assistance for them, so really cool flash stuff. You need your basic memory cards and hard drives so you can store your data. Backup batteries are always a good idea. And you'll take the align images, and then it will mix the 3D scan data as well as all the photographs to create a final model. And from that point, you can go through the same process that we just discussed. And you can go to the next slide. So now we'll get into just a little bit of the 3D modeling and texturing. I can't get into too much detail here because a lot of the techniques were a bit proprietary, but I'll give you a general walkthrough. So the first thing that we need to do to get the asset into a game engine is to create the low poly asset. As mentioned, these data sets can get really, really big. I believe the tomb started out at about 5.2 billion or 6.2 billion points, and at the end of the day, our mesh ended up, I believe, around a couple 100,000 polys, which is pretty crazy. When you guys see the demo, and to know that it was only a couple 100,000 polys and the rest is all textures and maps, it's pretty amazing. Speaking of the maps, we have to bake all of our maps. We bake our diffuse, our normal, and our ambient occlusion. The diffuse map is the D-lit map that contains all the color information but doesn't contain any shadows. Your normals are going to give you a lot of the details and the cracks and crevices and the paint strokes and all that. And the ambient occlusion is just going to give you a little bit of extra of that. So you can use something like X normal, like I mentioned. And what you need to do is you need to take your high poly model and then you bake out all the information from your high poly model to your low poly model. And then that's that. You got to clean up the geometry as mentioned before using Maya, Cinema 4D, ZBrush, whatever your choice of 3D modeling software is. To me, that's one of the most important parts because with photogrammetry, when you go into these experiences, you start to feel like you're really there. And then once you get to one of these ugly parts where all the geometry is screwed up, it just takes you completely out of it. So it's a waste of time to do it in the beginning if you're not going to do it right. Retopologized geometry, as mentioned before, makes it a lot easier to work with in post-production. And if you use something like Instant Mesh, it does it by itself. You click one button and it's already doing it for you. Reprojecting the textures. So once we clean up our geometry, we need to take it back into reality capture so that we can reproject the textures onto the new geometry. Fairly simple process. Once you get through the initial process of using reality capture, you'll be able to do that no problem. And then cleaning up the textures. So as mentioned, we had some things in the tomb that we weren't able to get rid of. When you guys see the demo, you'll see that the floor is made out of rock, but in the actual tomb, it is a hardwood floor. We did not want that. We didn't want it to feel contemporary. We wanted it to feel like it would if you had gone back there 3,000 years ago. So we had to clean all that up manually. So you're going to need to use things like Photoshop and Substance and Marmoset to make sure the textures are cleaned up and that all the textures like the wood grain would be gone and replaced with rock or whatever material you'd like to use. And now we'll just discuss a little bit about Unreal Engine and how we put it in there. And this is a photo of the end result. This is not a picture. This is actual in-game footage. You can go to the next one. And this is pretty much just photos. There's not really much to discuss. I think most people here are pretty familiar with the game development portion of everything. So we chose UE4 because the lighting is amazing. As you can see, it's gorgeous. The Unity experience didn't come out quite as good, so we're pretty much in the boat of UE4 going forward with our next projects. Yep, so another great thing about UE4 is the particle system is really easy to use. The VFX pipeline is really easy with UE4. Just in general, I've always liked UE4 personally because it's easier for me to use. The interface is a lot more friendlier for people who are just getting started. So I would definitely suggest working with UE4 if you're going to work with photogrammetry. And you can go to the next slide. And I think I just pretty much mentioned most of that stuff. So, and then just another photo of this is in the stairway leading down. As you can see, the lighting is really great. It captures the reality of the experience like it was when we were there. And that's pretty much going to do it for me. So please visit us online at Experius.com. Check out Curiosity Stream. They're an awesome service, and they are the reason that you're all able to even see this experience. It cost a lot of money to make, and they pretty much lost all of it just to make sure that we could all see this really cool experience. So check them out, check us out, and the experience is available for free on Steam, on the Vive Store, and on Oculus Store. So check it out. Thanks, guys.
Data did you capture all places? We're going to have spirit animals that are going to take us to, direct us and give us directions to everywhere we go. And then, once we go to the store, they're going to cry and say they're going to die if we don't buy stuff at the store. It's going to be great. And the school's going to be really cool. It's going to be amazing. The hype is real. In fact, there's science behind how much the hype is real. This is a very phallic piece of futurology right here, this chart going on. This is called the Gardner Hype Cycle of Emerging Technologies. Anybody ever seen this hype cycle chart before? It's really fascinating. It essentially says that technology, as it comes into the world, goes through different stages between the idea all the way into production. And the hype doesn't quite match up to actually its maturity. And this tries to place all these different emerging technologies, from energy to my favorite, like the digital twin and general artificial intelligence. But over here, coming up on the slope of enlightenment, we have augmented and virtual reality, followed by some of my other favorite technologies. I would definitely check this out later. I absolutely love the hype. I'm always captured by it. This is a photo of me a decade ago trying to chase all these emerging technologies. It wasn't, none of this AR VR stuff was ready then, and it's just starting to get there now. So I love making this magical, these magical experiences, writing this magical software. Up top here is some of my favorites and some of the best examples I've seen in AR, VR, machine learning being brought to the consumer. And if you want to do this, you want to make some magical piece of next-gen tech, you have to walk between the software and the hardware, and everything between the software and hardware is laid out here. Under apps, we have libraries and frameworks, it's where languages live. Then we get down lower and lower until we start to hit the OS level APIs. Then we start getting into assembly, the actual pieces of dedicated hardware, and then into the devices themselves. And when you're making software that's really rich, you have to essentially navigate this whole labyrinth. And the two guides that people use are Unity and Unreal right now. That's kind of the big major thing, is build a platform that can get your access to the get your software access to the hardware and back again with performance, get you that 3D rendering, get you those computer vision, get you machine learning, get you access to sensors. Let's continue. So let's slice off a piece of that first. Let's talk about the state of the XR, AR, VR, everything in between. AR really is going to hit us in the broad market first in our phones. And the first way it's going to be delivered to our phones is through the app stores. If you're on iOS or Android, you're getting AR through ARKit and ARCore. You can see right here they're about comparably matched, and this chart's getting updated all the time. Keep going. And then if you want to do VR, there's several options out there. Probably everybody's familiar with standalone, tethered, and phone-based AR out there. It's a whole ocean of different devices and all sorts of problems trying to target most, if not all of them. Then we get to the AR world. I bet most of you are familiar or are not familiar with many of these headsets, but there is a pretty interesting AR ecosystem that's starting to boot up. I'm sure most of you are aware that Magic Leap is about to drop here, and some of these other headsets are starting to get a lot broader adoption. Over here are some of my favorites that nobody knows about, which is the open source headsets. Let's keep going. Then some of the other ways that AR and VR is coming. Projection mapping and projection AR. This is one of my favorite systems, the Lightform, just kind of showing how cheap this stuff is. And then other forms of AR, perspective 3D. This is AR wall right here, doing perspective augmented reality. There's other companies and other frameworks like HeadTrack doing it for free too. And this is all different ways that we can see XR starting to come online. And really what's underneath all this stuff, that's helping us power it, that I think gets very little attention, is actually the sensors themselves. This is probably the most talked about sensor of the last 2 years. Does anybody know what this is? It's a really easy hint. It's the True Depth module that you see on the iPhone X. Apple actually bought 3 different modules and glued them together for about $16. It's not even worth $16 now. It's about $8 to manufacture. They're really amazing technology that they have, and you can see right here, it's a dot projector, an infrared camera, an RGB camera, and it's able to do all sorts of spatial sensing. You can also see there's a long list of other types of sensors out there. Let me show you a few more sensors that you don't know about that are coming online that are going to enable some amazing experiences. Here's one in ultra low power coming out of Cornell University, really made the public about a month and a half ago. This is a 1080p camera that works at about 15 frames per second and requires no battery. You hook up this antenna and it picks off power from ambient EM, runs the camera, and then transmits the video back over ambient EM. And this chip's $11, going in production at the end of September. Pretty crazy, right? Want to see another sensor you probably haven't heard about? This one was announced Monday by Sony. It's 48 megapixels. That's not an inch, that's a centimeter. Okay? So just imagine the photogrammetry you could do off this, like time machine. It's just having the right database access rights. And it's going to be the backbone of which the metaverse is going to be built on, because it's what's going to place all this photogrammetry and all this rich data into the world. And that's where the Chronos Group comes in, right? Chronos Group is creating and maintaining essentially the pipeline to build all the 3D, the 3D logic, and then do it in virtual reality and augmented reality, layer on parallel computing, all these great pieces of machine learning on top of it. And they're doing a great job. They're getting all the boats, all the oars in the water, all the boats going in the same direction. We're all getting into the same destination. We're doing this around common formats. I think we talked about OpenXR got called out. I could get on my soapbox and talk about all of these for a really long time, but I won't. The big point is you've got to follow this guy, Neil Trevitt. He is the vice president of NVIDIA, and he's also the president of the Chronos Group. He talked at the Embedded Vision Conference, which is pretty much the biggest conference that Chronos Group does, about a month and a half ago, and he pitched his big idea. And I'm going to show you the big idea in a second. It floored me. It's the most ambitious thing I've ever seen in computer science. You guys ready? Here it is. This is the formula for the singularity. What he essentially decided was, how do you take XR and you build a system, a framework, so you can be training machine learning models in real time, doing inference in machine learning models in real time, capture the whole world in volumetric space, whether it be a light field, a point map, polygons, what have you, be running software on top of this, no matter where from, where to, and have it interact with heterogeneous hardware, heterogeneous sensors in a huge quorum. And this is going to be this is the XR workflow to kill them all. And it's coming to all the hardware you just saw and all the ones that is coming out. And it's pretty wild. Really, where this is all getting sorted out right now is with the emerging standard of OpenXR, which really gets like sensors and the software that runs on top of it and all the optics that runs on top of it into a common framework. And that's going to start in XR and blow out in a bunch of different directions. And the other side of this, it's a very similar track that the Kronos group is doing, is in neural networks. Essentially, they're building these interoperability formats, NNEF and ONNX. They both pretty much do the same thing, and it pretty much allows you to take heterogeneous pieces of hardware, run heterogeneous training systems for machine learning, get a common trained format, and then bring it over to heterogeneous inference systems. So you can go deploy your machine learning model on a phone, on a desktop, in an embedded piece of hardware, and they all run the same. It essentially allows you to go from anywhere to anywhere. So we're going to see that with software, we're going to see that with machine learning, we're going to see that with 3D models, and it's the thing that's going to be most interesting is finding the common frameworks here. So you guys, let's all take a breath here. Probably going, Liam, it sounds, I believe you, it sounds like we have a holodeck on our hands. And now I know what the next question is. Is it like that first episode in Star Trek The Next Generation where the holodeck's awesome? Or is it like every other episode? WebAssembly, which is a really awesome technology that is actually allowing us to compile web code before it's delivered to you, so it'll run, it'll download to your browser super quickly and then run really incredibly fast. And you're gonna see browsers be able to give web pages a ton of RAM and a ton of computing and a ton of GPU power, so it looks like a native app. It looks like something made with Unreal or Unity. And then, last but not least, WebTorrent and all the things around it. Anybody heard of WebTorrent? I bet this is the one that no one's ever heard of. WebTorrent is an incredible technology that uses BitTorrent and BitTorrent-like backbones to allow all of us to pull our caches together that run on the back of our browsers. So somebody can distribute out technology, like a ton of files in real time, and they don't have to be like a YouTube for it to, for like streaming video to be received by millions of people at once through a totally decentralized way. It's also great stuff you can do with crypto blockchains on top of all of that. WebGL Angle requires a shout out. That's another great technology that's coming online to really make the web a place for 3D. And this all feeds into the next thing I want to talk about, which is something that most people don't really know, which is computer vision and machine learning can now be done in the browser. You can both train in the browser, you can run machine learning models in the browser. The latest instantiation of this technology is coming in shader compiled machine learning, where machine learning systems are actually compiled into WebGL shaders so they can run in the browser through the GPU at speed. There's similar work being done with crypto as shaders as well. That's really making the web the most interesting place to develop right now. So I assume everybody's sold. So I'm going to explain to you a little bit how it works. So now you guys want to build your amazing, magical next-gen apps on the browser, and I'm going to show you kind of how it's going to run. So these are the four major browsers out there, and I figured I'd give you a little clue under the hood on how this relates to the underlying Kronos technologies that make it all possible. So the first one up is Mozilla, my favorite, and it's using WebGL Angle when I'm building my AR/VR experience to talk down to the new hotness Vulkan, which is the operating system's take. Now let's actually start over a little bit because I think I'm getting a little dense. So get the hell myself. So you want to run a really killer 3D AR/VR machine learning app. You're going to have to load it up on a web page, and then that web page is going to get opened up in a browser. And that browser is going to have some 3D rendering horsepower given to it, and it's going to have some access to sensors. And depending on what browser you choose and what operating system you're on, you're going to get a slightly different experience. Pretty much the best experience around is going to be Firefox. And you can just kind of follow this chart together. If you're on Android using Firefox, you're going to be using the latest and greatest underlying systems, along with a ton of access to native sensors. Same thing with Linux. But say if you're an op on Windows or everything to do with your gaming trophy case or your photo stream of your children or what have you, and turn it into a physical dynamic object like a living scrapbook. And here's an example of one of our WebXR prototypes. This is essentially a world covered with all the points and lines of everywhere you've been. You can place anywhere in your space. You can walk around. You can interact with. And this is a globe of you. No. And you can hear my breath really heavily. So, yeah, and this is running in Chrome. And you can see there's no marker. And I'm able to walk around the entire experience, move in, move out. And this is all running from a universal plot. And I've amazed myself that nothing has crashed. So, yeah. Yeah, so the next steps are essentially solidifying this end-to-end system that we've built, and then starting to layer in more machine learning, more blockchain storage, more essentially intelligence and decentralization to really make this the ultimate platform to encode all of our lives, a real objective reality. And we built this with trust and control in mind. You know, I think we've all seen the trends of Silicon Valley, and I don't think anybody wants these trends to continue. So I started with the principle of building this nose-to-tail open source, building it in such a way that as much of it as possible is distributed, and making sure that people are not the products. That this is a product for people. And if you'd like to know more, you can check out our website, my white paper, and the slides are online. Thank you guys for your time.
Yeah.
Any questions? Sure.
Seems like everything's focused on visual data. Do you deal with sound fields? There was a mention of voices, but I didn't hear anything about capture.
So sounds pretty easy. We essentially want to start building like a page that's a capture page. And you can essentially say, I'd like to record sound, or I'd like to record video. And then on top of the sound and video, you can say, I'd like to record a transcript. I'd like to place the transcript against people's sound profiles. So I know this is John's voice and Sarah's voice. Tone, affect, emotion, accent, all of these things can be captured. Actually, you can then reverse extrapolate things like vocabulary and all sorts of other things. And then, yeah, similar systems with video. It's essentially, all these sensors out here can do a range of things, and I'd like to build an abstracted framework. So, given heterogeneous sensors, you can run whatever type of capture you want, and then store it. So, the idea is, if you want to capture a moment, turn all your devices on to lifescope.io/capture. Decide what you want to capture from that device, and it just records time. And then when you want to go back, you pop on your VR headset or pull out your AR device, and you play back time. And it looks very, Minority Report, where it's volumetric and experiential. But it's just encoding reality, replaying reality in all the ways possible. Yes?
I can see this being useful for parents, However, I'm wondering if you get a phone from your employer, how do you prevent them from
think of a
taking
lawyer.
over?
It's like, think of this in Discovery. I think this has 1,000,001 use cases. Everybody is building some part of this. It seems like we're all building the same thing. We don't really know what it's going to do, though. I want anything capable of doing this for any use case to be built in an open way. Because you're totally right. There's so many ways this can go wrong.
But to protect yourself as an employee, if you have a phone from your employer, do you have something built in to turn it off?
So we built this for the individual and only the individual right now.
Uh-huh.
So you use it for you. You have control. You create, collect, destroy your information. Giving employers godlike amounts of power over you, where they can see, they can how many times has James farted? Like, you don't really want that. So, it's going to, I wish I had incredible solutions for all these problems. I just know that the solution is not, requires us to all have the most amount of power possible.
Looks like it's going to take a massive amount of storage. So where do you get funding, money to buy the storage? What's your business model?
So actually, we use a bunch of dirty tricks to get the storage way down, and a lot of that is offloading the storage to other services. But yeah, I can get into that later. Yeah, there is a massive storage problem, but it's not as bad as you think.
So is this going to go in the direction you're talking about rebuilding someone's